This video contains some exercises that you should work through. So there is a file that you would have downloaded for this section of the course. It's called On-Ramp Desktop Exercises. And you can see that there are three exercises. And so what you should do is go through and try to follow the instructions and write some code to complete these exercises. If you haven't done that already, then please stop the video, pause the video, and work through these exercises. Get as far as you can and see if you can solve them completely. What I'm going to do now in the rest of this video is walk you through my solutions to these exercises. Okay, so exercise 1. Generate a sequence of odd numbers, and then for each element, add 5 and divide by 2. And then repeat the sequence for even numbers. So there's a couple of details that are omitted here, like where the sequence should start and where it should end, but that's okay. We can just guess that it's going from, let's go from 1 through 9. So we want to generate a sequence that should already ring bells in your mind of the colon operator. So we can do 1 colon 9, and this is valid code. We're not getting any errors or warning messages, but it's obviously not what we want. We want just the odd numbers. So in fact, when you look at this sequence, you can see we want to keep this number, not this one, not this one, this, and so on. So in fact, we just need to skip by 2. So I'm going to write 1, skip 2, skip 9. And that gives us the odd numbers. So that's this part of assignment 1. And now for each element, and this is the element. So this is the first element, the second element, third element, fourth element, and fifth element. So for each element, add 5 and then divide by 2. So let's just work on this part first. We want to add 5 to each of these elements. So this is going to be 6, and then 8 and 10 and so on. So how can we do this? Well, you might think of doing something like this to say, add 5 to this sequence. Now, if you tried that, that is a good idea, that's good thinking, but it's not the right solution. Because in fact what Matlab is doing is grouping the 9 and the 5 together. So Matlab is interpreting this line of code as 1, skip 2, skip 14, and that's why we get up to 13. So what we need to do here is use parentheses to tell Matlab explicitly to group these terms together separately from this term. So now I can copy and paste here, and we get 6, 8, 10, 12, 14, and that is the right answer here. Then we want to divide by 2. Now again, if you are thinking that it's this simple, then unfortunately it's not quite the right answer. And that is because this is going to end up adding 5 divided by 2 to each of these elements, when in fact what we want is to group these together and then divide that result by 2. So I'm going to use parentheses again, and now we finally get the correct answer here. So 3, 4, 5, 6, 7. All right, and then repeat for a sequence of even numbers. So what I'm going to do is copy and paste this here. Now, how can we get this to be even numbers? In fact, it's not so difficult. We just need to change this. Now, there's a couple of ways you can do this. I'm going to change this 1 to a 0. So let's see. Then the answer happens to be 2.5, 3.5, 4.5, 5.5, and 6.5. All right. I'm going to call that successful completion of exercise 1. Let's move on to exercise 2. Here we have a line of code with a lot of parentheses, and most of this is stuff I showed you in the previous video. I didn't show you this. This is a function, sqrt. You've probably guessed that it's the square root, and functions work by having parentheses, and then the input into the function is whatever is in between the parentheses. So this whole expression here means to take the square root of 9, which of course is 3. So copy and paste, and there you go, we get the number 3. Okay, so delete as many parentheses as possible without changing the results. Let's actually start by, I think I will copy and paste this here. So we are going to leave this one unadulterated, and this line of code, I'm going to start deleting some parentheses. So the answer turns out to be 3,125, whatever that means. Maybe that's the number of chocolate bars per year that a certain teacher eats. Actually, I hope not. Or maybe that's okay if they're really, really, really tiny chocolate bars. Otherwise, that's an excessive amount of chocolate. Okay, so let's see. We want to start deleting parentheses. One nice feature of Matlab is that if you click on one parenthesis, you see this underlines here, and it underlines the corresponding opening parenthesis. Now, that's useful because here you see that this expression here has double parentheses. So one set of parentheses is often useful, and two parentheses is typically not useful. Now, before changing the code even more, I'm going to run this again just to make sure we are still getting the same result. This is an important principle in science and also an important principle in coding, that you should test your results after changing one thing. It's not good to change 10 different things in the code and then test it, because if something goes wrong, it's hard to know which of those 10 things that you changed made the mistake. Okay, and now looking at this, I think this is also not necessary. So 2 plus the square root of 9, which is actually just 3. And just to be on the safe side, make sure that we still get 3125. Okay, so we can try with this set of parentheses. Now, when we remove this parenthesis, it turns out that Matlab is going to prioritize this power over this addition. And I can prove that by running this code, and now we get a totally different result. In fact, this result is whatever this evaluates to squared plus the square root of 9, which is 3. Okay, so we discovered that this set of parentheses is really necessary. We cannot get rid of it. And then we have, and that actually also qualifies for, or that applies equally to this outer set of parentheses here. However, I'm curious about this inner set of parentheses. And I think I'll even put some spaces in here. And maybe I'll do that here also for consistency. Okay, so now the question is, do we still get 3125? And the answer is yes, and that's because Matlab, like everything else in arithmetic, is prioritizing division over addition. So this is 9/3 plus 4/2, and it's not 9 divided by 7 divided by 2. All right, so that's basically as good as we can get. That is all of the parentheses we can remove without changing the results. Okay, now on to exercise 3. So this is where the fun really starts. Here we convert sequences. This is actually something that comes up pretty often. You might want a sequence that goes, 10, 100, 1,000, and you start off with something like this. So convert the sequence 246 into -1, 0, 1. So here we have our sequence 246, and how do we get this to be -1? So, you might think of doing something like subtracting 3, but of course that's not going to work because I need parentheses. So here we start off with -1, so that part is good, but this is still skipping in 2, and we actually need to skip in 1. But that is the key insight here, that this is skipping in 2. So what I'm going to do is add parentheses here and divide by 2 and then subtract 2. So now let's see what this ends up being. So here we get -1, 0, 1. Now, if you're thinking, yeah, Mike, why do you have to go through all this ridiculous stuff? Why don't you just write it like this to start from? Of course, that is also a good idea, but the point here is to think about how to use the colon operator and incorporate the colon operator with simple arithmetic problem solving. Okay, so here we get the next sub-problem on this exercise. So we start off with this sequence, and we want to convert that basically into powers of 10. Now, the key to this is to appreciate that the sequence 10, 100, 1,000 can be obtained by taking 10 to the power of 1, 2, 3. So this is 10 to the power of 1, 10 squared, and 10 cubed, so 10 to the power of 3. So therefore, what I'm going to do here is first convert this sequence into a sequence that goes 1, 2, 3. And the way that I'm going to do that is simply by adding, 2. So we converted -1 to 1 into 1, 2, 3. And now the next thing is we need to do 10 to the power of all of this business. Now I'm going to put another set of parentheses around here. And then we do 10. Now I told you that it was 10 caret and then, the power. But this is actually a sequence of numbers. Let's see if this works here. So we get an error. Now, if you're just getting started with MATLAB, and also if you're not super comfortable with linear algebra, this might be an indecipherable error message. It says incorrect dimensions for raising a matrix to a power. This looks a little weird, but the solution turns out to be element-wise powers, which is what we want. So we're going to use the dot caret. I'm going to have more to say about when to use. So there's like multiplication, and then there's dot multiplication, and there's division, and then there is dot division. I'm going to talk more about this later on in the course, but basically most of the time, if you get an error or if something is going wrong with multiplication, division, or powers, it's pretty likely the case that you want to do dot power, which is the element-wise power. So element-wise power of 10 to this sequence, 1, 2, 3, and that gives us 10, 100, and 1,000, which is the desired output. Okay, now if you thought all of these problems so far were weird and you had much better ways of solving them, then that's totally fine. But this one actually is something that comes up often in practice. So I often need to generate sequences that look something like this, where it's a bunch of increasing numbers that repeat for some period of time. So we want to start off with the sequence 1 through 9 and end up with the sequence 1, 1, 1, 2, 2, 2, 3, 3, 3. Now, it turns out this is easily the most difficult problem in this entire set of exercises, and that's because it relies on a function, and I haven't yet told you about functions, and I didn't tell you the particular function that you needed. So if you really struggled with this particular problem, then don't worry about it. It's using some concepts that I'm going to introduce you to very soon in the course. Okay, so I'm going to start by dividing this by 3. Now let's see what that gives us. So here we have the sequence 1 through 9, where each element gets divided by 3. And that gives us 1/3, 2/3, 1, 1 1/3, 1 2/3, and so on up to 3. So you can see this isn't what we want, but if you notice that by rounding all of these numbers up to the nearest integer, we actually will get the desired outcome. So round up, then this becomes 1 and 1. So not just rounding, because then this would be 0, but you force to round up. This would be 1, 1, 1. This ends up being 2, 2, 2, and rounding up will give us 3, 3, 3. So how do we round up? In math, rounding always up is called taking the ceiling. So we want to take the ceiling. So there's a MATLAB function called ceil, which stands for ceiling, not to be confused with, the animal seal. So ceil for ceiling. And then what we input is the numbers that we want to take the ceiling of. So copy and paste. And then you see we get the numbers 1, 1, 1, 2, 2, 2, 3, 3, 3. And that is the desired outcome. Very nice. I hope you enjoyed working through these exercises. I hope you found it to be a nice balance of familiar concepts and straightforward implementations with a little bit of challenging and problem solving here and there.